Okay, for 6.4, we're doing linear inequalities. So these are solved very similar to our equations that we did in the last section, but now we have that greater than, less than or equal to, those symbols, right? That are inequalities. So let's just write a little note over here to make sure you remember these symbols. So there is less than. So you're saying the number on this side is less than the number on this side, right? If I read it backward, I'd be like, this number is greater than the number over here. So make sure you're not just, you have to think through it, not just put the symbol, but that is a less than, this is greater, this is less than or equal to, and this is greater than or equal to. So less than, greater, and it's always, the alligator eats the biggest number, okay? Less than or equal to, or equal, and this is greater. I have to put an equal sign there because I don't have room. All right, so you're less than or equal to, greater than or equal to. And what is the difference on solving these in a math problem versus an equal sign? Well, it means you have more than one answer because you're just less than or just greater than something, or you could be equal. But like in general, if I say any number less than 2, the answer isn't just 2. The answer is any number less than 2. So there's a lot of answers. So we can graph our answer and we can write it in inequality form, or we can write it in interval notation. Oof. Just like totally slit my brain. Okay, so let's go down here and look at some examples of just like kind of the notation and stuff. So this is called set builder notation. You don't have to write it, but your answers and your problems might have that. What this notation is, it's saying the set, those are set brackets, of all numbers x, such that is the line, such that all those numbers x are less than 3. So you're saying the set of numbers that meet this criteria, and that criteria is they're less than 3. So it's kind of a funky notation, but what is the piece that we really need to focus on is this piece, right? The numbers, we're saying all numbers such that all the numbers are less than 3. Okay, if we went to draw this, maybe if I scroll in, you could see it. Does it? No, it stays a little fuzzy still. So you can see that this is an open dot right here, right? And then it's going less than, and it has the arrow down here. Notice this one is a closed dot. So let's make a little notation on here so we know that if I have, oh goodness, I don't really have a place to put it. Let's go back up here. If I have less than or greater than, I use an open dot. Okay, if I have or equal to, I use a closed dot. Okay, in interval notation, this would be a round bracket. In interval notation, this would be a square bracket. So those are just to kind of help us with the graph. So if I go down here to this first one that we were just looking at, sorry if I went too fast, just push pause for a second to write that down. But okay, so down here, this should be an open dot. Oops, let me draw that. It should be an open dot at 3. And I usually do my arrows up above. Doesn't matter to me. I only do it so you can for sure see which way my arrow is going instead of going like this on the line. A little harder to read. But we are saying the numbers are less than 3. So under our arrow, those numbers here better be able to be put here and work. So is -3 less than 3? Yes. Is -2 less than 3? Yes. So you can see that all. Okay. And then, so the next one is greater than or equal to. So again, that's going to be a closed dot, and you're now greater than. Now notice when you start with the X, that this arrow is pointing you in the right direction. It is. If your X is first, it points you towards where you go with your arrow. One other thing for both of these is sometimes you might see this like this with this bracket. So this one would be a square bracket and this way. round bracket. And why would we use those symbols instead of open and closed dot? What can you type on a not a calculator, but on a computer? Can you type an open dot? No. Can you type a round parenthesis? Yes. Could you type a square parenthesis? Yes. So that's where that idea comes from. Okay, last concept is kind of like going in between numbers. So you have this compound inequality. And what this is saying is read it from the middle. All numbers x such that x is greater than -1. Okay, x is greater than -1. See how I read it this way? I mean, -1 is less than x is the same thing. But if I read it from x, it just makes more sense for me. So x is greater than -1, and x is less than or equal to 3. So x is greater than -1, but it's less than 3. Okay, so we're in between, right? A compound inequality. We're in between those two numbers. Now notice this should be a round or open, and this should be closed. Can't quite see them on the graphs there, so I'll make them really big. And then it's any number in between here. All right, so again, lowest number to highest, less than, less than. You have to go that way for that symbol. Then I put in a little English thing over here just so we remember that this is what these are each saying, okay? Just to help, at least, at most, no more than, no less than, you just to kind of help with those. Because if x is at least 5, could it be more than 5? Well, yeah, so it's greater than. If the most you can have is 2 children in China, then you could have 1 child or no children, right? It could be less than 2 or equal to 2, right? This one has 5, but that's just the rule I thought about on the top of my head. X is no more than 5. Okay, it could be less, but it's no more than 5, so it's less than. X is no less than 5, right? And then it can be greater. Okay. Let's start with some graphing of these solutions, these inequalities, and then we'll build our way up to solving them. So x is less than 4, so I go to 4, and do I do a round open circle, or do I do a closed? Hopefully you said open. And which way, left or right, do I draw my arrow? Less than, this way. Okay. Next one is greater, so we go to the -2, and it's or equal to, so we do closed, and it's greater. Okay, could this have been a square bracket and greater? Sure. Could this have been a round bracket? Yes. We don't see that as much on the graphs, but we do see that on occasion. So C, I am greater than -4, right? But less than 1. If we read that from the center. So we're going to do, oh, and it's equal to on both ends. So we can do closed dot here, closed dot here, and you're larger than this one, but less than this one. So it's just that whole section, any of those numbers. Okay. They kind of go at each other, but it doesn't pass this. You can't do it this way. I've had students do that. No, it stops. So you can't, that's illegal move, illegal math move. So you can't have those. Right? It's just in between. Okay, now let's start to solve some of these. So we look at this first one here. So we want to start with getting the x's together, right? So we have a 6x over here, 8x over here, and we want to, I always go to the left because we really like the x on the left side for these, right? So that it's pointing you in the direction. So I always go to the left. And that's what I'll do here. So I'm going to minus the 8x minus the 8x. So now I have -2x minus 12 is greater than 2, right? Because this goes away here. And that's where we're at now. Okay, so now we still are looking at this x term right here, and we have to get rid of the number first by the opposite operation. So we're going to add the 12, and now I have negative 2x is greater than 14. Now this is where it gets a little tricky. So I'm on the very last step. I'm about to do division. If I divide by a negative, I have to switch the inequality sign. So let me say that again. If I divide or multiply by a negative, I have to switch the inequality sign. And that's because it switches the way the numbers work. I thought that was on the top. Yes, okay, it is. I'm going to scroll up just for a second. Right about here. It says when multiplying or dividing both sides, it will reverse the direction. Okay. I forgot to mention it when I started, right? You got to star that, circle that for yourself. And so this one, I'm going to divide right now, and I'm going to divide by a negative. And I divide both sides by that. That's going to switch the direction of your inequality. So this becomes 1x, which we want, but now it's going to become less than, negative 7. And that's because of the way negatives work. And, your arrow can only go one direction or the numbers don't work. So what we're going to do is we're going to graph this and we're going to put a number back in and make sure it worked. So I'm going to put at negative 7. That's funny. My graph doesn't even go to negative 7. Just go like this, right? Here's negative 6, negative 7. Perfect. And do we want a round bracket or do we want a open bracket or closed? I called it a bracket. Open dot or closed dot? Open dot, right? Or round bracket. And it's going to the left or to the right? Hopefully you said to the left, right? That's not a very good arrow sign. Those are my arrows. Okay, that way. Here we can highlight it. This way over here. So what is a number that would be under that arrow? Well, maybe negative 8. So I can do a little check over here and I can say, okay, 6 times negative 8 minus 12, is that greater than 8 times negative 8 plus 2? I ran out of room. Oh, and my face is kind of over that. Okay, so I'm just going to put that in my calculator or calculate it real quick for yourself. But 6 times negative 8 minus 12 is going to give me negative 60 is greater than 8 times negative 8 plus 2 is going to give me negative 62. Negative 60, is that greater than negative 62? Yes. It's negatives, right? So yes. You could do a number line to think of that, right? Negative 62 is more in the negatives than negative 60. Just thinking about the number line to help you with which one's bigger. Cool. So that's that first problem there. Now, we still are just doing all those steps the same. And then on that last step, we either switch the inequality or we don't. You should not be switching the inequality all the time, right? It should be rare on that last step. Okay, if you divide or multiply by negative. So let's simplify this one. And I'll just do a little line across here so we have a little room. So let's start with distributing that 2 and that 8. So on the left, I would have 2x minus 6, okay, distribute, plus 5x is less than or equal to 8 times x is 8x. 8 times 1 is 8. Now I got rid of those, but I can still simplify a little on that left side. So let's go ahead and do that. We have a 2x and a 5x. So that's going to add to 7x. And then you still have the minus 6 is less than or equal to 8x minus 8. Okay. And I like to, again, move my x's to the left. So I'm going to minus 8x minus 8x. That's going to give me a negative 1x or negative x. Minus 6 is less than or equal to negative 8. This part went away. Okay, so then opposite operation, add that 6, add that 6. And I have 1x or negative 1x, or negative x is less than or equal to negative 2. Last step, I'm going to divide by a negative 1 or times by negative 1. And that's going to switch the inequality And I end up with a positive x is now greater than or equal to positive 2. Okay, so go over here to 2, closed dot, because it's got the equal and greater. Okay, for this greater. The check will take a while, but put any of these numbers in, make sure they work. Okay, and check your work, because it's really easy to do the arrow in the wrong direction. All right, number 3. So this one this one's like way easier. I'm not sure why this is not number 1, but whatever. I'm gonna add the 7 to both sides, right? And that's gonna give me 4x is greater than or equal to 7 plus 5 is what, 12? I was double checking because to me, um, in my brain, I was thinking it was divisible by 7 anyway, instead of 4. It's all right. So then divide by 4, divide by 4. I was like doing the next step in my brain. So I would have x is greater than or equal to 3. That's not a 3. Boo, boo, boo. Okay, so x is greater than or equal to 3. So then from here, I'm going to go to the 3 and I'm going to do a closed dot and greater. Okay, this one's pretty easy to do our check with because it's an easy function, right? So a number under there, maybe 4 or 5. So 4 times 4 minus 7, is that greater than or equal to 5? Okay, so 4 times 4 is 16. 16 minus 5, 16 minus 7 is going to give me 9. So 9 is greater than or equal to 5, and that is a yes. So this is true, right? It worked. Okay, so on number 4, if I have 1/3 x, I could also write that as x divided by 3 like this. Those are the same thing. 1/3 x, both of them. Dividing by 3 is the same as having a third, right? I'm breaking it into 3 pieces and I have one of them. So how do I solve this? I times by 3, right? Or 3 over 1. So times both sides by 3. It's not a negative, so we're not switching an inequality. It's positive 3. So we're going to times this side by 3 and this side by 3. And that's going to give me just x, because this is like 3 over 1, right? So those cancel. Is less than 15. And that is definitely not on my graph. Let's just add a little 1 right in front of that 5 and call this 15. And you're less than. Maybe look those, yeah, sure, be counted by, I don't know, 12, 13, 14, 15. I have a little break in my graph. Let's do this. Break in the graph. No, that's fine. Okay, last one on this little section. What if I have a negative 3x is less than 21? Well, I'm going to go to divide by that negative 3. And what's going to happen? It's going to switch the inequality because I divided both sides by a negative. So x becomes greater than negative 7. Okay, x becomes greater than negative 7. So here's our negative 7 way out here, and you're greater, and it's an open dot and greater. All right, so you could easily put in a number like negative 4. So negative 4 times negative 3, is that less than 21? So yeah, I was second. So negative 3 times negative 4 is positive 12. Yes, that's less than 21. Yes, 12 is less than. So yeah, and you could do 0. 0 times negative 3 is 0. 0 is less than 21. So still getting a yes, yes, yes. Okay, one thing I want to just pause and have you think about. If I have this, oh, let's do it the other way. That'll be harder or easier. If I have this, 7 is less than x. So I solved my inequality and I end up with this. How can I rewrite it to do the graph right and put it in my math lab right? Well, switch it around and make sure that the symbol in the middle switches with it, right? So the X is got the greater, it's being eaten by the alligator on both of them, right? So you can switch around an answer. So if you went that other direction, you can just switch your answer. Just make sure to switch the inequality as well. So X is greater than 7, or 7 is less than X. Those are saying the same things. But it makes way more sense to say it as X is greater than 7. Numbers, just numbers are greater than 7. Okay, so this last couple here, this number 6 here, it is saying, okay, I have a compound inequality. So you could break this into 2, or you can do it to both sides is kind of the idea. So I'd like only an X in the middle. And right now I have 2X plus 1. So what I can do is I know if I ignored this piece, right? I'll just put my little pin on it. And I just looked at -3 is less than 2X plus 1. I know I would minus the 1 first. But what I do is I minus the 1 from both sides like this. So then the first number is going to become -3 minus 1 more is -4, is less than 2X, is less than or equal to 2. Because these ones go away. 3 minus 1 is 2. So now we're here. Now thinking it through, what would be the next step is to divide by 2 to get the X completely alone, but we just do it to both sides. So divide by 2, divide by 2, divide by 2. I get -2 over here is less than X is less than 1. I didn't divide by a negative, so underneath with the 2 was not negative. We don't care if you have negative numbers. We only care if the number you divide by is negative. So we don't have to switch anything. And we're going from -2 to 1 on our graph. So, oops, this one should have the line. I was like, one of them was one way. Yep, I just forgot that line on that one. So at -2, you are an open dot, and at 1, you're a closed dot. And X is greater than this one, and X is less than this one. So it's all this in between. Right, read it from the middle. X is greater, X is less. Okay, last problem. To earn an A in a course, you must have a final average of at least a 90%. On the first 4 examinations, you get these 4 grades. If the final examination counts as 2 grades, what must you get on that final to earn an A in the course? Okay, so let's think about this. We have a first grade of an 86, and if we want to do the averages and the mean, we add them all up and divide by how many there are. So first test plus second test plus next test plus the 84, plus I have to add the final exam score twice because it's double. You could have wrote that as 2X, right? That could same thing, but I kind of just wrote it as X plus X. Now, to do the average, you add up everything and then you divide by how many there were. Well, there is 1, 2, 3, 4, 5, 6 total tests, grades that count. And we want this to be greater than or equal to 90, right? Because that's how you can get an A. So let's solve this. First of all, if I'm dividing everything by 6, how can I get rid of the 6 right away? Because it's under everything, right? It's not just under one number for the last step or anything. I can times it over. So I'm going to start with 6 times 90. I'm cheating because I don't know 90 times 6. Well, I know about what it is. So it's 540. So here's where I'm at. I have 86 plus 88 plus 92 plus 84 plus x, or plus 2x is greater than or equal to 540. What does that number 540 really represent? It represents how many points you had to earn on the 6 exams to get the 90. Okay, now let's simplify that left side. Let's add those numbers. So 86 plus 88 plus 92 plus, I wrote 8x. 88. No, it was 84. Excuse me. I was like, why does it say 8x? You probably already noticed. All right, plus 84. All right, 350. So this whole side is 350, and we know x plus x is 2x. Now we're almost or pretty much at something we can solve now. So then we're going to get the x by itself. So the 350 has to be minused over first. So I'm going to minus that, and I get 2x is greater than or equal to 200-ish or 190, almost 200. 190. Okay, divide that by 2, and ooh, that's kind of a good grade. Ooh, hope we can study. X is greater than or equal to that to a 95. Whoosh. We have to do pretty good on that exam. We have to get better than a 95. So, yeah, so that's how we can kind of think that one through. I did have a little at least at most to kind of help with some of those questions, little cheat sheet chart. All right, I think that's all I got for this section.